other developers and technical documents overcomplicate Docker. If you're brand new to Docker, then here's a mental model that I want you to use. So, you can think of Docker as your own custom operating system that runs on any computer, any server, any cloud infrastructure, anywhere. Okay? So you build this OS via a Docker file, and then you can turn it on via a simple command. Now you have a virtualized Linux computer at your disposal. Hello, Midnight Coders. Have you ever wondered what it takes to get your application that you just made into production? Docker is one of the most widely and popularly used choices amongst developing teams when it comes to getting things up and going effortlessly and confidently. So, today we are going to break down Docker, not in technical terms, not in overwhelming jargon, but real talk. So, make sure you've got that full cup of coffee. Mine's not very full, and let's dive on in. What is Docker, you might say? Well, imagine that you have just spent weeks of your life writing your Java project, and it seems to work perfectly on your computer. So you decide to send it to a friend, and then all of a sudden they go to run it, and boom, it explodes. But you could just tell them it worked on my machine. I know, frustrating. We've all heard it before. And Docker exists to kill that phrase. So you can think of Docker as taking your application in the exact version that it needs, the exact Java version, the exact libraries, and everything else that it depends on, even the operating system environment that it expects. Then seal all that up into a shipping container and set it off to sea. Not a virtual machine because it actually shares the host operating system rather than emulating an entire computer. So it is a shipping container. This is Docker. Docker is a container ship at sea. It doesn't care what's inside the containers, just that it has cargo to carry. And you can just package up your image and tell Docker to create and run a fleet of containers from this one image. Whether it's on your laptop, whether it's on your desktop, AWS, Azure, Raspberry Pi, the next Silicon Valley Internet, doesn't matter. If Docker supports that platform and you built your image correctly, it's going to behave the same on every system. All right. So what the hell is an image? Think of a Docker image like a frozen snapshot of an application environment that's ready to go. And all you have to do is run it. It packages your code, Java, every dependency, the environment, everything into a single portable package. And now every time that you run that image, Docker's going to create a fresh container so that no matter where it runs, it's going to behave the same. So, how exactly do we build a Docker image? Well, we create a new file in our project called dockerfile. And in here, you can think of Dockerfile as a blueprint or a recipe for an image. It is a legitimately step-by-step guide to make your favorite cake. We all love cake. So now we use caching and stages so that we don't repeat ourselves. We do things in specific orders so that we don't have to repeat ourselves either. See what I just did there? So, from the top of the file, we use it as a build stage. So, we'll say something like from Eclipse to Temuran, we'll say the version is 25, JDK, and we're going to slap on Alpine as the build. So now Alpine is a minimal Linux distribution that's commonly used to keep images small. Then we're going to create a working directory. Then we're going to copy over all of the files that we need to for our Gradle project. From there, we are then going to change the modifiers of the Gradle W file to include execution. And from there, we're then going to run the Gradle command to fetch our dependencies. We're going to copy over our source code, and then Gradle compiles everything and packages the application into a runnable jar. Next, we have the runtime image itself. And again, we're going to start here as from the Eclipse Temuram version 25 JRE. So we're going to slim it down and use the JRE, not the JDK. Next, we're going to provide a label that is then going to also associate with a version so that we know how to reference this label later. We're then going to create our working directory. We are then going to create a non-privileged, non-root user, copy over the generated jar that we had just done, name it app.jar, and finally, we then switch over to the non-root user and define the command that's going to run once the image comes online. You can think of this as opening up your terminal and typing in a command, java jar app. So how do I actually use Docker? Well, let's say that you have a product that you want to host. It's got a database, a backend, and a front end. Typically, each one of these has its own container. Docker doesn't actually make your application faster. It just makes deploying your application predictable. So, how do all of these communicate with each other? Well, this is where Docker Compose comes in. And you can join me next time as we dive into Docker Compose, what exactly it is, what exactly it solves, and how you can level up your home lab with a controlled, managed network of container ships. So, as always, guys, keep your curiosity open, your skills sharp, and that coffee cup full. I'll catch you in the next one.